These are chapters 8-3 and 8-4 combined together. Please copy your cuts for 8-3, similar polygons, and we'll also have 8-4 in this lesson. Similarity. Similar figures. What similar figures mean is when I have two or more figures that have the same angle measures but their sides are proportional. Not exactly the same size. For example, if my classroom were one size, let's say the classroom is here, okay, and it's square shape, and it's a 20 or rectangular shape. I say a 24 by 25. But let's say we have a gym, same particular shape, and it's two times as large. That means it will be a little larger in size. So this might be 48 by 50. And 48 is the bottom piece here. I'll move it over here. Let's say this is the gym over here. This will be 48 by 50. Okay? Well, they are similar because they're the same exact shape, but what's different is the lengths are different and the widths are different. I know they're similar because I can see that my classroom, see, is half the size of the gym. Or if I'm doing classroom compared to gym, notice the code for comparison, it's a 1:2 ratio. It's 1/2, in other words, if I write it a fraction. Or if I wanted to compare this as gym to classroom, I know it's a 2-to-1 ratio. The gym is 2 times larger than my classroom. Now listen, this is what's important about similar figures. If I say that the gym is 2 times larger than my classroom, that means every side must be 2 times larger. So in other words, to go from the length of my classroom and the length of my classroom, if it's 24 feet, if I say the gym is 2 times larger, that means if I multiply by 2, I get 48. This 2 is my scale factor. And if these are truly similar figures, the classroom and the gym, that means every side must be 2 times larger. So that means if I look at the width, I did the length, 2 times 24 is the 48. If I do the width as well, it better also be 2 times larger. So if I multiply this by 2, that means automatically if the gym is similar, it means that the width of the gym had better be 50. Well, 25 times 2, look at that, it's 50. Therefore, because every side is exactly 2 times larger on the gym, then that means that these two figures, the classroom and the gym, both the sizes of those rooms or figures are similar figures. Now look, if the width of the gym had been 60, and I look at the length, well, how do I go from 24 to 48? Times 2, I see it's 2 times larger. That works beautifully. That means the width had also better be 2 times larger. Well, 25 times 2 is not 60, so that automatically means these are not similar figures. Every single side better be multiplied by the same exact scale factor or ratio. Okay, and again, similar figures, when 2 or more figures, I could do, let's say, my classroom, I could do the gym, and then I could do the school might be 5 times larger than the classroom. Okay, and it might be several times larger than the gym. Similar figures is 2 or more figures have the same measures, but their sides are proportional. Now, what's going to be true also about similar figures is this. When I look at similar figures, their angle measures will be exactly the same, regardless of the size. So if this is my classroom, and this is the gym over here, okay? If the angle measure for this over here, this angle was 60 degrees, that exactly means that this angle here on the gem is 60 degrees. It doesn't matter that this is 24 to 48 in feet. The side lengths are proportional, but the interior angles must exactly match one another on similar figures. I'll say that again. Side lengths, the length and the width, something like that. The side lengths are proportional. It's 3 times bigger, it's 18 times bigger, it's 11 times bigger. Those have to be proportional. But the interior angles, all of the angles, they must be exactly the same measure. It doesn't matter the size. Okay? These will always be exactly the same measure. All right, scale factors. Similar figures use scale factors, a proportional ratio that relates corresponding sides. Here's theorem 8.1. All right, let me erase this here. All right, theorem 8.1. If two polygons are similar, then their ratio of their perimeters is equal to the ratio of their corresponding side lengths. What does that look like? And we're in your book. You can open your book up and look these over. So I have 2 figures. And I'm looking at this figure, KLMN, corresponding or being similar to, and I use a squiggly line, means similar. Similar to PQRS. And when they are both similar like this, what that means is I put them in the same exact order. K corresponds to P. L corresponds to Q. M corresponds to, down here in the corner, R, and then N corresponds to S. No, KL is not the same length as PQ, but what's true when I said about similar figures, angle K is going to be exactly the same measure as angle P. So if this is 48 degrees for angle K, P will also be 48 degrees. But their lengths, PQ and KL, will not be the same. They'll be, this might be 8 times larger, PQ might be 8 times larger than KL. But going back to theorem 8.1, if I take the perimeter, you know perimeters when you add up all the side lengths. The perimeter of this polygon or quadrilateral, KLMM, is going to be proportional to PQRS. All right, what does that look like? I will move a little further. Here it is. Now, if I say KL is 4, LM is 5, MN is 7, and NK is 6, and I know that I'm given the sides here for PQ to be 8, QRS, RS is 14, and SP is 12, there has to be a similar proportional ratio. There has to be a proportional ratio, excuse me, because they are both similar. There has to be a proportional ratio because they are similar. What does that look like? If I add the perimeter, that's 4 plus 5 plus 7 plus 6, which is 22 for KLM. And I'll do this as small to the large. And the perimeter of the large is 8, 10, 14, 12. Its perimeter is 44. Okay? That simplifies down to 1/2. So their ratio is 1 to 2 if I'm doing small to large. So that means if I'm comparing small to large, the ratio is 1 to 2. And if I go the other way, large to small, it's 2 to 1. Okay? That's if I do the perimeter. I can pick sides. The sides must still follow this same ratio of 1 to 2. What do I mean? Let's say I compare side KL, I'm doing small to large. Let me move this over a bit. If I do the small polygon over the large, and I do KL compared to, of course, PQ, if I figured out that the perimeters proportional ratio is 1/2, each side length must be exactly the same thing, 1/2. So if I get small or large, that's going to be KL is 4 over what's PQ, 8. If I simplify that, the ratio again is still 1/2. Let's check another one. Let's look at LM. If I'm doing small to large, LM compared to QR, and L corresponds to Q, so I write it in the same order, and M corresponds to R, so I write it there. What's the length of LM? It's 5 over QR is 10, and again, the ratio is still 1/2. So I can compare all of these fractions or side lengths, and they should all be proportional with the 1 to 2. Okay? So if I do the ratio as small over large, you need to be consistent and do always small over large. Now, if I chose to go the opposite way and go large to small, large over the small, okay? Let's say I'm comparing SR to what? NM. SR to NM. That means that SR over NM is going to be 14 over 7, which is equal to 2 over 1. Okay, that means if I were doing a perimeter, I would have to go large over small. It would be what? 44 over 22. See? And I'm just showing you that order does matter. It's going to be 2 over 1. Okay? I'm just showing you that order does matter. So be careful about the way a person calls something out to you. If they say small to large or large to small. Okay? Next item of business. Using Theorem 8.1, the perimeters. Okay? This is just the information, how we will write it out based on the example I just gave you. Theorem 8.1, the perimeter of KLM is 22. And the perimeter of PQRS is 44, or the ratio is 22 to 44. And using 2 of the corresponding sides, if I chose to compare, as I already did, okay, KN, well, KN is here, and its length is 6, and that means I automatically have to compare it to the corresponding. What corresponds to KN? Well, that means that I have to compare P and S in that order. PS is going to be equal to 12. Okay? Or it's going to be 6 to 12, which is equal to 1/2. Okay? Perimeter compared to side is 22 over 44. Here's the perimeters. 22 over I'm doing the small over the large. And I'm comparing perimeter to the side. That's a colon. So I'm comparing P to S. Perimeter to the side. When I do perimeter to the side, that's going to be 22 compared to, let's see. Well, I'll just leave it like this. I'll leave it as a fraction. Let's see, perimeter side. I'm comparing the perimeter on this side and the side lengths over here. The fractions are still the same. This is going to be 1/2, and this is also 1/2. Okay? And I'm going to actually put 8.4 on another video.